Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, use the known values of epsilon naught, h, m, and l. H Planck's constant, m mass, epsilon naught is used. This is a physical constant while studying dielectric constant, dielectric permittivity of free space, etc. Okay, dear students, we have to use these values up to 5 significant figures to find to confirm the values of Hc in electron volt, E square over 4 pi epsilon naught in electron volt nanometer, above is also in electron volt nanometer, A naught Bohr radius in nanometer, and E naught in electron volt. Okay, dear students, use the following values of epsilon naught, h, m, and l to calculate the following 5 significant figures. Hc in electron volt into nanometer, nano standing for 10 to power minus 9, E square over 4 pi epsilon naught in electron volt into nanometer, same as above. Okay, Bohr radius A naught in nanometer and E naught in electron volt. Dear students, these 4 things are such. We are going now. We are going to its solution. In solution, we will take into consideration a table of physical constants in which all these values will be given exactly. We have to just counter check them by alternate method. Okay, so we are going to its solution. Okay, dear students, this is the first snapshot in which a table of physical constants is shown in which many physical constants are included. Okay, dear students, from this table we will use the value of speed of light c, we will use the electronic charge E. Anyhow, we first come towards Planck's constant. Okay, dear students, value of Planck's constant at h is given at serial number 4 and value of speed of light c is given at serial number 1. Similarly, combined value of hc is given at this second last serial. Okay, second last row, hc equal to 1240 electron volt into nanometer or million electron volt into femtometer. Okay, so dear students, our first part is 100% completely solved in this table. Okay, not only the value of Planck's constant h is given and not only the value of speed of light c is given, but also combined value of hc which we have to show is given, also given. Okay, so in this problem, just as a formality, what we will do, we will multiply the value of this Planck's constant h with c, this and see whether this value becomes equal or near very closely close to this value. Okay, similarly, dear students, in this table this value is given, E square over 4 pi epsilon naught equal to this. Okay, actually we have to find out this value while its exact value is given in this table, but dear students, here we are seeing that value of E separately given in second row. Okay, similarly value of pi is 22 by 7, that is 3.14. However, value of epsilon naught is not included in this table. For the value of epsilon naught, we will take another snapshot. Okay, in that snapshot we will see that value of 1 over 4 pi epsilon naught is also given as a separate measurement. Okay, then so in other words, dear students, while calculating this value, that is e square over 4 pi epsilon naught, we have two alternate methods. Okay, one method is in which we take this value of e, okay, and then value of pi 3.14, that is 22 by 7, and then value of epsilon naught from other snapshot. Okay, and other method is in which we take the combined value of 1 over 4 pi epsilon naught as a single value and then multiply it with the square of this e, which is given in the second. Okay, now dear students, a naught Bohr radius, it is also given 0.0529 nanometer. Okay, but we have to confirm it by using the definition of Bohr radius and putting the concerned values. Okay, similarly hydrogen ionization energy 13.6 electron volt, remaining part is concerned with this. Okay, but we have to counter check all these four values or factors or parameters, etc. Okay, now dear students, we are going to second snapshot in which basic masses are discussed. Some basic masses, basic masses of proton, neutron and electron. Okay, charge on proton is plus e while charge on neutron is 0 and charge on electron is minus e. Okay, then their masses are given. Okay, first in masses are given in terms of kilogram and then in terms of atomic mass unit. Next to this, a minor hint is given which will also be availed in this problem, that Newton into meter is equal to joule and Newton is equal to kilogram meter per second square. Okay, these are by definitions of these terms. Okay, this conversion will also be used here. Okay, yes students, now we are going to other snapshot. Coulomb's law, magnitude of electric force between 2 point charges. Okay, F is equal to 1 over 4 pi epsilon naught. Okay, this is called electric constant into q1 q2 mod or absolute value or magnitude divided by r square, where r is the distance between the two charges and q1 q2 are the values of the two charges. Okay, the constants in equation number 21.2 are approximately epsilon naught is equal to 8.854 into 10 raised to the power minus 12 coulomb square per newton meter square. Okay, we will use this value of epsilon naught, and dear students, this is here combined value of 1 over 4 pi epsilon naught, which is denoted by k, is also given as 8.988 into 10 raised to the power 9 newton meter square per coulomb square. Okay, so dear students, while confirming or verifying the value of e square over 4 pi epsilon naught, we have two methods. One method is in which we separately put the values of e and pi and epsilon naught and then calculate and we see what result comes. Second is that we take combined value of 1 over 4 pi epsilon naught this and multiply it with the square of e. Okay, then next snapshot is about Bohr radius a naught equal to epsilon naught h square over pi m e square. Okay, next first Bohr radius a naught equal to h cut square over m k e square equal to 0.0529 nanometer, nano standing for 10 raised to the power minus 9. Dear students, this is not Planck's constant h. This is h cut or h reduced or h bar. This h cut means Planck's constant h divided by 2 pi. Okay, here m is the mass of electron, k is electric constant, which is 1 over 4 pi epsilon naught. Okay, this k is not kinetic energy, etc. This k is 1 over 4 pi epsilon naught, and this is elementary charge, electronic charge e square. Okay, now This is the expression about E naught. Okay, dear students, because we have also to verify the value of E naught. So in this book, that is Modern Physics by Stephen T. Thornton, equation number 4.26 deals with this parameter. E naught is equal to E square over 8 pi epsilon naught A naught. This alternatively becomes equal to E square over 8 pi epsilon naught into me square over 4 pi epsilon naught h cut square. Okay, dear students, we have to distinguish between Planck's constant h and reduced Planck's constant h by 2 pi, h divided by 2 pi. Okay, this alternatively becomes equal to me raised to the power 4 divided by 2 h cut square into 4 pi into epsilon naught whole square, and this is alternatively equal to 13.6 electron volt. Okay, now next snapshot is also about E naught. Okay, energy levels in hydrogen like atoms are given as E naught equal to minus z square into E naught over n square, where E naught is equal to minus mk square E raised to the power 4 divided by 2 h cut square. Okay, dear students, here m is the mass, k is 1 over 4 pi epsilon naught electric constant. Okay, E is electronic charge or elementary charge, charge on an electron, charge on a proton. Okay, divided by 2 h cut or h bar or h reduced. Okay, this is Planck's constant divided by 2 pi. Okay, this is alternatively equal to 1 k E square over 2 a naught, where a naught is Bohr radius. This is alternatively equal to 13.6 electron volt. Okay, so dear students, now we are going to our solution in a proper manner. Now we part first, okay, hc in electron volt into nanometer. Okay, value of h in that table is given as this separately, and value of speed of light c is given this separately, and when we multiply these two we get this. Okay, this. Okay, dear students, our answer becomes hc equal to 1239.9728 electron volt into nanometer. Okay, so exact answer, which according to table is 1240. This is also 1240, no doubt, because digit after decimal is greater than 5. Okay, this is 9, and its next digit is again more than half. So this difference is negligible. Okay, so it means we have reached about exact answer, which was 1240 electron volt into nanometer. Okay, now we move to second. Okay, second, E square over 4 pi epsilon naught in electron volt into nanometer. Dear students, in about this I had explained that there are two methods. In one method all these values are separately taken, and in the other method value of 1 over 4 pi epsilon naught is one value and value of E is second value. We can solve it by just two values. Okay, but here we have adopted the practice in which we have used 1 2 3 4 values. Okay, three values, 4 is a constant. Okay, E equal to 1.602 minus 19 coulomb. Okay, this is the elementary charge, electronic charge, charge of a proton, charge of an electron. This is included in the table. Okay, which is included in snapshots. Okay, pi is equal to 22 by 7, and this is taken as 3.14. Okay, moreover value of epsilon naught is also introduced in a snapshot, which is 8.854 into 10 to the power minus 12 coulomb square per Newton square meter per Newton meter square. Okay, this implies that E square over 4 pi epsilon naught will become equal to this in the numerator in square divided by 4 into pi into epsilon naught. Okay, so next there is just simplification. Yes, students, we should not waste time on simplification steps. Okay, because this is almost middle class mathematics. Okay, dear students, here coulomb square will be cancelled with coulomb square. Moreover, because Newton into meter square is in the lower part of the denominator, so it will be shifted to upper part of the numerator. Moreover, dear students, because Newton into meter is equal to joule, so Newton into meter square can be written as joule into meter. Okay, because Newton into 1 meter will be converted in joule, while 1 m will still remain as it is. Okay. Then, dear students, we have converted joule into electron volt according to the same formula which we had shown previously. In that table, in the last, it is given that one electron volt equal to 1.602 into 10 raised to the power minus 19 coulomb. So, dear students, for the time being, we once again go to that snapshot. Okay. This, okay, dear students, 1 electron volt is equal to 1.602 into 10 raised to the power minus 19 joule. So 1 joule will be equal to 1 divided by this multiplied by 10 raised to the power plus 19. Okay. So dear students, so this, dear student, yes. Okay, E square over 4 pi epsilon naught is equal to this. Coulomb square will be cancelled with Coulomb square. This becomes equal to this. Newton meter is equal to joule, so it will become joule into meter. Now we are converting joule into electron volt. Okay, so this value is 1 divided by 6.602, 1 divided by 1.602, this result is that, and this is 10 raised to the power plus 19, because we had seen that this is equal to this, then this will be equal to this. Okay, so this becomes equal to this, electron volt into nanometer, electron volt into meter. Dear students, next step is just as a fashion, as a facility, as a formality, because we have to give answer in terms of nanometer, and we know that nano means 10 to power minus 9, while we have our answer in term of 10 to power minus 7. So what we will do, we will shift this decimal 2 stages ahead. Okay, by shifting this decimal 2 stages ahead, this power will also increase by 2. Okay, so when we write instead of 0.014425 as 1.4425, then this 10 raised to the power minus 7 will become 10 raised to the power minus 9 electron volt into meter, because this factor is called nano, so it can also be written as 1.4425 electron volt into nanometer. Okay, now we come towards the next part. Okay, next part, a naught Bohr radius in nanometer. Okay, this is the formula for a naught, which was included in 2 or 3 snapshots. Okay, a naught is equal to pi naught, oh sorry, a naught is equal to epsilon naught h square over pi m e raised to the power e square. So this is equal to, this is the value of epsilon naught, this is the value of epsilon naught, and this is the value of h. Okay, actually dear students, a figure in the denominator was lengthy enough, that is why it has been split in 2 parts lengthwise. Okay, this multiplied by this, these both values are included in the numerator, while in the denominator this is pi 3.14, and this is the mass of electron 9.109 into 10 minus 31 kilogram, and then this is the E, this is the value of elementary charge, electronic charge, charge of an electron, charge of a proton. Okay, this next Just simplification, just simplification, just simplification. Here, dear students, clearly Coulomb square will be cancelled with, we see in the next step. Several factors will be cancelled out, okay? So this becomes equal to this. We have made a conversion factor as we had made some conversion factors in previous part, okay? So Coulomb square has been cancelled with Coulomb square over Newton meter. Okay, dear students, this portion has been converted into this portion after cancellation of some factors and some conversion factors. Okay, those conversion factors have been clearly indicated before starting this problem in a regular manner. Okay, so this just simplification. We will not explain simplification steps. Okay, just simplification, just simplification, just simplification. This becomes equal to this 5.2876 into 10 raised to the power minus 11 joule square into second square divided by Newton meter square into kilogram. Okay, then we see what happens next. This becomes equal to this into joule second square per meter into kilogram. This becomes equal to joule per Newton. Okay, joule per Newton. This becomes equal to joule per Newton is equal to meter. So in place of joule per Newton, we have used meter. So in the next step, 5.28 becomes 0.5. If we write it in this form, then this will be converted into 10 raised to the power minus 10 in the place of minus 11. If we so what we have done here, we have shifted decimal one step back, and in the next step we have shifted it one step more back. So that is why 10 raised to the power minus 11 became 10 raised to the power minus 10, and then it became 10 raised to the power minus 9. This is equal to 0.052876 nanometer. Because 10 raised to the power minus 9 is called nano, so we can write this figure as 0.052876 nanometer. Dear student, next hint is given that because Newton into meter is equal to joule and Newton is equal to kilogram meter per second square. Okay, these two definitions have been applied in this problem as conversion factors. Okay, Newton into meter is equal to joule and 1 Newton is equal to kilogram meter per second square. Dear students, now we have started our last part, E naught in electron volt. E naught is equal to E square over 8 pi epsilon naught into A naught. Okay, this value of E has been taken from the table. Moreover 8 as it is, this is pi 3.14. This is the value of epsilon naught. This is also included, taken from snapshot. However, the value of A naught is that which we calculated in the previous step. Okay, Bohr radius. So this is that value. Now remaining just simplification and some conversion factors. Okay, just simplification. We do not explain these simplification steps. So after simplifying all these steps, we finally reach the conclusion that E naught becomes equal to 13.7324 electron volt. Actually, dear students, its exact value is 13.6. So no doubt we admit that our answer lacks accuracy. Okay, in place of 13.6 our answer has become 13.7, but nevertheless it is very close to the exact value. It is very close to the exact value. Dear students, sometimes accuracy can be compromised by, but methodology cannot be compromised. Okay, so we have adopted exact method. So by adopting exact method, even if accuracy is not obtained or secured, then it is not a blunder. Okay, so I think our last part has also been solved satisfactorily. The only minute negligible difference is that our answer should become 13.6, but here after our answer is becoming 13.7. Okay, so this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.